You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Good morning, everyone. My name is Bob Keene. I'm the editor of Fire Ecology and the host of Fire Ecology Chats. Today, we're very pleased to have Alina Kanzler. She just published a paper called "A Large Database Supports the Use of Simple Models of Post-Fire Tree Mortality for Thick-Barked Conifers, with less support for other species." This is an incredibly important paper. It's rare that people have done a comprehensive review of most mortality. Alina, could you tell us a little about yourself?
Yeah, my name is Alina Kanzler, and I did this work while working for the USDA Forest Service Rocky Mountain Research Station at the Missoula Fire Science Lab in Missoula, Montana. I now work for the University of Washington in Seattle for the School of Environmental and Forest Sciences.
So, Alina, why would someone want to read this great paper?
This paper evaluates empirically derived statistical models that are used in management decision support systems. And these decision support systems influence how managers do prescribed fire, when and how, and what they do after a fire across the United States. Also, globally, these types of models are used in many other places around the world. So it's a really important system for making decisions, and we wanted to bring some data to bear on how well that system was working.
What did you use for data?
Okay, so this is what's so neat. This evaluation of post-fire tree mortality models is the most comprehensive one to date. We evaluated 44 species, and we were able to do that because of a database we built for this project, which could be used for many others. It's called the Fire and Tree Mortality Database, and it's published and available on the USDA Forest Service Data Archive. And it contains data from 41 contributed data sets from across the United States of post-fire tree injury and survival and mortality observations. So there's 170,000 tree level observations in that database. For this paper, we used about 93,000 of those tree observations.
Oh, so it looks like the data support the use of the equations for the fire-adapted trees or the trees with the thick bark. Why won't it support the other trees that have more thin bark or adapted to competition?
So the models that were made and used in the first order fire effects model were developed initially from thick-barked western conifers. These are the tree species like ponderosa pine and Douglas fir that we often are concerned about when we're reintroducing fire or managing fire in western fire-prone dry forests. But this model, as it's built into FOFM, the first order fire effects model, can be applied to any species for which there's a bark thickness coefficient, so you could estimate bark thickness. What we found was for thinner bark conifers and for angiosperms, so any of the hardwood species, the prediction accuracy was much lower. So approximately 75% of the models tested had excellent to outstanding predictive ability, but for these other species, maybe we need to take a different modeling approach than this logistic regression equation based on crown damage and tree bark thickness.
So you mentioned FOFM. The results of this study have been integrated in FOFM?
They have not yet been integrated in FOFM. So what we did in this study was evaluate the models that are already in there and show how they work and what direction the errors are. We didn't develop new models for this study. And one of the things that comes out of it is because the errors are related to species and taxa, that maybe for those species, like say oak species, we need to really rethink the modeling approach of how we're modeling mortality for those species.
Oh, so it's safe to say that this is probably the most comprehensive review of tree mortality we've had in quite some time.
It is, and there's been a lot of work in the past to develop new models for one species at a time, but we'll probably need to keep improving the models we have to make predictions in the short term, but also think about different approaches, maybe machine learning approaches, or addressing whether the bark thickness estimates are correct for a group of species for thin bark conifers and angiosperms in the future.
Oh, okay. So would you like to recognize any funding agencies?
Absolutely, yes. So this work was funded primarily by the Joint Fire Science Program, and that funded the bulk of the mortality database and the analysis, but we received some additional funding from Rocky Mountain Research Station and the National Fire Plan. And I should also mention the we in this is Sharon Hood was a really important lead on this project, and Phil Van Menkem with the USGS, and Morgan Barnor, who's now with Tall Timbers Research Station.
Well, thank you very much, Alina, for coming to Fire Ecology Chats. And we really appreciate your time. And everyone, if you want to read this wonderful paper, it is only available from the journal Fire Ecology. Thank you very much, Alina.
Thank you.